Okay, so this is puzzle 714. This was our 5-year anniversary puzzle from an older electron density puzzle. I no longer have the puzzle on my hard drive, so all I have left is this screenshot. But I wanted you to notice some things about the side chains. So after I've got most of the backbone into the places I think are right, then I start looking for individual side chains to help confirm that I'm in the right spot, or to tell me that I need to move the backbone up or down a little bit. So some of the things I look for, down here in the lower left, these hydrophobic side chains, these orange ones that are shaped like paddles, often make good landmarks. This is the kind of paddle that has a tip on the end. And in a very clear electron density map, you'll see a pocket for this paddle that's narrow on both ends and wide in the middle. And that's a clue that that's the kind of side chain that goes there. Over here, closer to the middle, is a paddle with no tip. And in a clear electron density cloud, you'll see a pocket for that that's narrow at the neck and wide at the end. And that's a clue that that kind of side chain goes there. Now, in the current electron density puzzle, the clarity is much less than in this example, and I'll show you that in a minute. But this is sort of the ideal case that I look for. Some other things that I've noticed, if you look here in the upper right, there are two long blue side chains, and they're not covered by any cloud at all. And this is not uncommon for the long blue ones. When you have orange side chains, they always have some cloud to go with them. But the long blue ones sometimes have no cloud at all, or they may have no cloud for the neck and then just a little blob for the head. Now, sometimes you can improve that by increasing the threshold, the way Karsten showed you, so that you're seeing more of the cloud. But sometimes it just isn't there. So if you've got a long blue one sticking out, you can't find any cloud to put it in, don't panic, that's normal. Here in the center of the protein, I've got 3 little Y-shaped orange ones in a row. And in this very clear electron density, each of them had a T-shaped pocket to fit into. And that's what you really want to find, is that the size and shape of the pocket in the cloud matches the size and shape of the side chain. Again, in the less clear electron densities, like the one that we're working on now, you won't be so lucky. But this is kind of the ideal case that you want to look at. One other thing that I learned on this puzzle, if you look up here in sort of the top center area, you'll see a hydrogen bond, this blue and white thing, that's connecting this orange side chain to this blue side chain down here. And in the electron density cloud, there is a little tunnel that belongs to that hydrogen bond. There's no side chain in the middle of this tunnel. It's the hydrogen bond itself that was visible enough to the electron density machine, whatever that is, that it could draw some cloud there just to hold the hydrogen bond. And I'll show you some of those in the current puzzle. Okay, so this is puzzle 750, the one that we're working on now. Oh, and I'll tell you another trick that I have. When I'm working on the backbone, when I'm first trying to fit the protein in the cloud, I like to use the solid electron density shape. For some reason, it's easier for me to see shapes in that, large shapes like sheets and helixes. But when I get down to the side chain level, I really prefer the wireframe. I'm going to make this just a little bit more see-through. For some reason, it's easier for me to see the small shapes in the wireframe. Okay, I want to look at this red side chain right here. This is one of those paddles with a tip on it, but it's hard to see because there's so much stuff around it. So I'm going to hover my mouse over that segment, and I'm going to press Shift-Q, and that's going to focus in on only things that are in the plane, the same plane as that segment. So you can see it zoomed in on it for me, and it has cut away a lot of the cloud that's not close to that segment. Okay, in this electron density cloud, there is a pocket for this segment. It's got kind of a blob on the end. It's a little bit narrower at the neck, not a lot narrower. I wish it were more narrow at the neck to be sure, but it is a little narrower at the neck. Now, it does not have a tip on it like that clearer electron density had. It's just a blob. But the fact that it's in the middle of the protein, which is where I want those large hydrophobic side chains to be, is a good clue. So I put that in there. I'll tell you, I originally had this one, which is like a double paddle. I originally had that one in that big blob, but I ended up turning it. Marie has often said that tryptophans, that's the name of this double paddle, is a tryptophan, that they don't mind being on the outside even though they're hydrophobic. So I decided if I could only hide one of them in the middle, I would hide this paddle with the tip on it and let the tryptophan hang out in space. Okay, now I want to see the whole protein again, so I'm just going to press the Q key without the shift, and it goes back to the whole thing. Let me see if I can find another example to show you. Here's a paddle. I'm going to use Shift Q to zoom in on it. This is on the blue helix. This is a paddle with no tip. And you can see it's got a blob to live in, a blob of cloud, but it doesn't really separate itself out with a visible neck and head, which is what I'd really like to see. But in this less clear density, it's just not separated out like that. You can see this is a big blob that even connects down to another part of the helix. So in the less clear densities, that's what these things can sometimes look like. It can just look like a very fat part of the backbone. Here's another paddle on the blue helix where the two of them, their pockets, their spaces in the cloud kind of glom together. They kind of mix together there. They're not very clear. Up here on the right, this is one of those blue side chains. You can't tell because everything's blue on this helix right now, but if you had it in blue and orange view, you would see this is a blue one of the long ones. It has no cloud at all, just like we saw in that screenshot. And that doesn't bother me because I've learned those long blue ones often have no cloud. Okay, I want to look at the sheets that Karsten picked out. Let me use Shift Q to look at these. Okay, I'm going to go back to solid view. I'm going to cut the threshold down just a little bit and look at those sheets. Now, I don't currently have any sheet bonds in here. I would like to see hydrogen bonds between these two sheets, and I'd like to see them being straight. They're kind of crumpled up now, so I've got some work to do there. But you can see there's a tube of cloud between these two sheets. That's where the hydrogen bond goes. That's not a place where the backbone connects to itself. It's a place where there's a hydrogen bond between these two sheets. So that's another clue to me, since there's one there and there's one over here. It's another clue to me that these are sheets, that they've got these parallel spaces for hydrogen bonds to go into. This greenish side chain here in my current build of this protein has 4 hydrogen bonds to the backbone, and you can see that there's a big blob of cloud that's filled up by the end of the side chain and by the hydrogen bonds. So that if I didn't have the protein in there, let me get that out of there, that might look like a big blob of backbone. But because I knew the backbone had to connect down here and it had to connect up here, I was left wondering what's going to fill up this blob here since it's not backbone. Well, the answer is it turned out to be hydrogen bonds. Another thing I wanted to mention, I'm not sure I have an example of it on this protein. When you're first looking at the cloud, let me take the protein out of the cloud for a moment. Whoops. When you're first looking at the cloud and you find a helix, sometimes you can see that the side chains coming off that helix are slanted in a certain direction. Like this side chain slants up, this one slants up, this one slants up. There's one down here that slants up. So most of the side chains on this helix are slanting toward the top of the screen. And that tells me that the lower numbered segments are going to be near the top of the screen in this helix. The higher number segments are going to be near the bottom of the screen. So when I'm fitting protein helixes into cloud helixes, sometimes I can find that clue that tells me which end goes up. So the side chains will slant towards the lower numbered segments in the helix. Okay. I think that might be, oh, I had one other comment. So I mentioned that the long blue hydrophilic side chains sometimes don't have any cloud. Sometimes they have a complete long pocket to fit into, but sometimes they have no cloud. But when you're looking at orange side chains, they will pretty much always have some cloud. You'll never find an orange side chain where the head has a blob and there's no neck. Now you might have to turn the threshold up a little bit to see the whole side chain, but there's always going to be some kind of a blob for an orange side chain. Let me turn this to blue and orange view so you can see that a little better. So when I'm looking at side chains and using them as landmarks, like, oh, there's a paddle here, where can I find a paddle to put in this space? If I find a space with no pocket coming out of it, this one's not a very good pocket. You can see my side chain is kind of hanging out of it, which I don't like to see. But if I find one where there's no pocket, or I find one where the pocket, the neck is missing and I can only see the head, then I'm much more likely to put a blue one in there than an orange one, because the orange ones generally have complete pockets. Up here at the top, you can see an orange one that's almost completely covered by its pocket. Now there are side chains in this density where the size of the pocket and the size of the side chain just don't match up. For example, this blue side chain on the right, the pocket for this thing is really long and even curves back into the rest of the protein. It's much longer than the side chain actually is, so it might mean that I put the wrong side chain in that spot. I don't see a longer one nearby in the helix that I could have put in that spot, so I'm settling for what I see there. But in a electron density cloud that's not high resolution, this one is not high resolution, it's kind of low resolution. Sometimes the size of the pockets won't match the size of the side chains, and you just have to come up with your best compromise for that. Okay, I think I'm going to turn it back over to Aunt Dean at this point.